Okay, let's take a look at solving a quadratic equation. And we're going to start out with the quadratic equation 3x squared equals 4x minus 8. And our first task when we do this is to get the equation to be set equal to 0. So I'm going to do that by subtracting a 4x and adding an 8. Opposite of the variables and numbers that are on the right hand side. Usually we really want that number with the x squared to be positive, so I'm not going to move that. When I move everything over, I don't have any like terms. Remember, I cannot combine the x with the x squared because they're not like terms. They have different exponents. And this is not something, try as hard to factor as you may. You cannot factor this lovely equation. So I am going to go ahead and use the quadratic equation. And just a little reminder, the quadratic equation looks like this. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And in order to do this, I need to get some values for a, b, and c. Remember, a is the number with the squared term. So in our case, it's going to be 3. B is the number with the x, or the single variable. So in our case, it'll be negative 4. And c will be the number all by itself, or in our case, 8. And I can go ahead and plug these in. Negative b is the opposite, so in this case it's going to be a positive 4. Plus or minus the square root of negative 4 squared minus 4. A is 3, c is 8, all over 2 times 3. And we're going to do some algebra. I find it easiest to deal with the inside of the radical first, so we'll take our negative 4 squared, turn that into a 16. We will take our negative 4 times 3 times 8 and get a negative 96. And we'll have that be all over 6. And then I'm going to go ahead and subtract what's in the radical. 16 minus 96 is a negative 80, all over 6. And I'm actually almost done. I just do want to do a little bit of simplification. And I'm going to look at that negative 80 and look for perfect squares that go into negative 80, or 80. And I'm going to say that 80 is 16 times 5, and we're going to make that 16 negative. Because when we take a negative out of a square root, we're allowed to do that as long as when it comes out it becomes an I. So this will actually turn into plus 4 plus or minus the square root of 4i, 4 being the square root of 16, and I being the square root of negative 1, or that negative sign. And the 5 is going to stay inside. And lastly, I'm going to try and do a little bit of simplification. Now, for some people, it helps to look at this as actually 2 separate fractions, each of which can be simplified individually. And I'm just going to break up the 2 pieces and see that 4 over 6 is equal to 2/3 simplified. And the same, this is actually a 4 over 6 also, so I can write that as 2i root 5 over 3. And you can then recombine that if you like, but you don't have to. If you want to leave it 2 separate fractions, you can leave it 2 separate fractions. But that is actually going to be our solution to our quadratic in simplest form. And remember that I represents an imaginary number, or the fact that we were dealing with that root of a negative, which we don't really like to do. So we take it out and turn it into what we call an imaginary number.